now we're on rule number 3 of reducing radicals. Okay, now rule number 3 says that you have no fractions inside the radical. So on number 15 on your notes, okay, I'm going to go through and explain what the process was to get that answer. First thing is that if you have the square root of 2/3, it is the exact same thing as saying the square root of 2 over the square root of 3. All you need to do is separate the fraction. Okay, this says the exact same thing. Okay, so now that we've done rule number 3, we've got rid of the fraction underneath the radical. Now we go back to rule number 1, no perfect squares underneath the radical. Well, there's not any. 3 and 2, those are not perfect squares. Well, let's see, can we reduce it? 2 over 3, radical to radical. Nope, we can't reduce it. So now we do rule number 2. We need to get rid of that radical in the denominator. We need to rationalize. So now we can take the square root of 3 and multiply it times both the numerator and the denominator. Okay, now I can multiply radical to radical. So 2 times 3 is the square root of 6. And guys, 3 times 3, well, guys, isn't that the square root of 9, right? And the square root of 9 is 3. Okay, now we have to ask ourselves, okay, can we simplify any further? Can I reduce the square root of 6 over 3? No, because I have a radical and a whole number. I cannot reduce those. So this is my final answer. Okay, that is simplified. Now we're going to go and I'm going to work out one of them with you on your assignment. So let's go look at your assignment and I'll work that one out with you. All right, I'm going to work out number 8 with you on your assignment. Now, number 8, okay, applies to rule number 3. We have, okay, a fraction underneath the radical, okay, no fractions underneath the radical. So the very first thing that I need to do, okay, is I need to make this, okay, the square root of 1 over the square root of 3. Okay, I take the fraction out of the radical. All right, now, what is the next thing that I need to do? What do you guys think? All right, so hopefully some of you said, okay, that rule number 1 says no perfect squares in the radical. Well, guys, isn't the square root of 1? That's a perfect square. That's 1. The square root of 1 is 1. Okay, so actually I have the square root, or excuse me, 1 over the square root of 3. All right, now what do I need to do? All right, so hopefully you guys said now you need to rationalize the denominator. Okay, so I take the square root of 3 and I multiply it both by the numerator and the denominator. Okay, so now in the numerator I have the square root of 3 over, well, the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. Okay, well, guys, what do I need to do next? All right, so hopefully you guys said, well, simplify if you can. Okay, well, let's look at this. We have a radical and we have a whole number. Can we simplify the square root of 3 over 3? No, because we have apples and onions, guys. That tastes gross. By the way, if you guys have ever eaten an apple and an onion at the same time, please let me know. I'd love to know how it really tastes. I just think it's in my head it tastes gross. Okay, so we have apples and onions, so we can't reduce those. So, ladies and gentlemen, as I break my pencil lead, there is our final answer, the square root of 3 over 3. Now, you guys are going to work through the rest of the practice problems in the assignment, okay, on your own. And you will do that during class so that you can ask questions. Okay, so that you can ask questions. All right, we'll see you guys in class. Have a great day.